Hello to you. I'm Jesse R. Johnson. I'll be speaking to you about permanent magnets and the principle of 13 to 15 laws and principles of permanent magnets. These simple principles, among a few others, can be used to make all types of machines, which includes permanent magnets. All of the principles stated on this video shall be illustrated with drawings. Hold on, please. I'm going to move the camera. To begin, there are two forms to magnets: attraction and repulsion. The red field shows what attraction is, north-south. The red field again shows what the repulsive field is, south to south. Number two, there are four modes, M-O-D-E-S, to all magnets. South-south, repulsive; north-north, repulsive; south-north, attractive; north-south, attractive. Number three, when two magnets are pulled face off, that's south and north attracting, pulled face off, looking at the arrows in opposite directions, they are pulled face off. It takes 100% the force to do so. Number four, when the same magnets, looking at the arrows and pulled from, slid off, that they are slid, they are attracting south to north, they are slid off in these directions, opposite directions by the arrows, slid off. It only takes 25% the force to do so. Number five, magnet A is stationary. Magnet B can move, as you see on the arrow. When they are attracting S and N, south and north, they are attracting. When magnet B is let go of, it automatically, under attractive force of the magnet, slides over magnet A. Number six. This is the first type of cancellation, Hall-back arrays magnetic cancellation. When you have magnets arranged in this form, a Hall-back array, where the arrows inside the magnets are in black, the arrows inside each one of these magnets is the orientation of the south and north poles. When you put them in this arrangement, the field itself is squeezed to one side, and that's called augmented. Almost no field is on the other side. When you squeeze the field all onto this side, almost no field is at the bottom. This is called canceled. The second type of permanent magnetic field cancellation, is field force cancellation. When you have two giant magnets, and they are repelling each other, such as north and north, they're repelling each other. The blue line shows, the blue field line shows how they look when they are repelling each other. But you put a piece of metal of an exacting thickness, an exacting width, and an exacting length between them, exactly in the middle. Exactly in the middle, the magnets themselves are attracted to the metal. If it's in the exact to the metal, and the red field line shows this. They're attracted to the metal but repelling each other. The attraction is +1, the repulsion is -1. +1 -1 equals 0, a cancellation. Number 8. The third type of cancellation is called crisscross cancellation, in which two permanent magnets are turned 90 degrees to each other, and within the cancellation space here, cancellation happens here because half the magnet up in here is attractive and the other half is repulsive. Therefore, they equal each other's forces right up in here, in this front view, right up in here. Magnet, and this is called crisscross permanent magnet, magnetic field cancellation. Number 9. This is magnetic shielding. You put a piece of metal in the front of an exacting thickness, exacting width, and exacting length in the front of a magnet, and the magnetic field will concentrate within the shielding, concentrate, where it will not come on the other side, and therefore any type of magnetizable metal will be unaffected by the field because the field is concentrated within the shielding. Shielding can be put on either side or even around the whole magnet. This allows things on the outside not to be affected, or things on the inside not to be affected by the outside. Number 10. When you take a moving magnet, such as this arrow, moving in that direction, the field, and it is near and over a electrical conducting wire, and the conducting wire is stationary, the field of the magnet will reorient the electrons and produce an electric current. When two magnets are attractive north-south, when they're attractive and they are slid from each other's surfaces in the direction of the arrows, before they completely reach the end, they repel each other at a small distance, the repulsion distance. When they get approximately 1/16 to 1/8 of their length, they will repel each other. Number 12, this is 12A. You can stretch fields, such as two magnets, north, south. The field is in red. When you pull them apart, you stretch the field a small amount. It's not a great deal, but it is a small amount of stretching. Compressed fields. When you take two magnets, north to north, and you repel them, and you push these magnets together, you compress the field. The blue outline shows that you can compress the field because they're repelling each other. This here is called 12C. 12C is where you can shape fields as you please. You can shape them. M1, magnet 1, magnet 2, magnet 3, magnet 4, magnet 5. Magnet 1 is rectangular, then rectangular. Magnet 2 is a triangular magnet. Magnet 3 is a block magnet. Magnet 4 is a block magnet. Magnet 5 is a cube magnet. And these are oriented such that south is south, repelling, north, north, repelling, north, north, repelling. Therefore, the blue fields shape each other because they're repelling, shaping each other because they are repelling. And the red, the field is stretched because the magnets are being pulled apart south to north. That's how you shape fields. Number 13, this is a wood holder. It is holding magnets 2, 3, 4, 5, and 6 in place. Magnet 1 is free to move. Magnet 1 and 2 are retracting north and south. This is the red field around here. This is called polarity, field, phasing. Polarity, field, phasing. The red is attractive. And the north of the number 1 magnet is repelling 3, 4, 5, and 6 because 3, 4, 5, and 6 are all north, 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 north. This creates a repulsive field simultaneously with the attractive field. The attractive field is pulling both these 1 and 2 together, but forcing 1, 3, 4, 5, and 6 apart. Therefore, they reach an equilibrium where there's an air gap right here between the wood holder, and number 1 magnet, and the field phasing is because the attraction, which is red, and the repulsion, which is blue, are simultaneous in the same space, unaffecting each other in the same space. Hence, attraction field is south-north, south-north, and the repulsive field is north-north, and therefore they lock number 1 in place, and number 1 can, if you move the wood part, number 1 will go wheresoever the wood part pushes pushes and pulls, because it is locked in place. I want to thank everyone for listening, and I want everyone to have a good day.